Lesson 8.3, Trig, sum, and difference formulas. So at the top of our screen here, we can see some formulas being given to us for the sum and difference of sine, cosine, and tangent angles. Also included in this lesson is a reminder of what is our Pythagorean theorem. It is used when given a right triangle and we have two given sides, whether they be two legs being given and we need to look for a hypotenuse value, or a hypotenuse leg combination being given and we are having to look for a missing leg value. So we use the a squared plus b squared equals c squared traditional formula, which merely means that a and b are the legs. Leg squared plus leg squared equals c represents your hypotenuse squared. Then we have the mnemonic SOHCAHTOA, reminds us the formulas of the ratios for sine, cosine, and tangent. They are all highlighted over here, OH, AH, and OA. And then when we are using the SOHCAHTOA ratio definitions, we must always stand at an acute angle. An acute angle is an angle less than 90 degrees. So in this particular example, we are standing right over here. So please notice that this is also an acute angle. But with respect to this angle, our opposite side will always be directly across. Opposite is always the leg that is directly across from your point of reference, which is this one right here. Adjacent is the leg that is being used to help form that angle where you're standing, okay? The angle that you stand at is always going to be made of your adjacent length and your hypotenuse length. Therefore, the side across, opposite, is always the angle, is always the side opposite the angle you're standing at. So basically what I'm trying to also say is if you were standing right here, your hypotenuse still remains hypotenuse, but now instead of opposite, because this side is being used to create this angle, this is no longer opposite, this is adjacent side if you are standing right over here, okay? All right, so all of the above is going to be used in completing the following problems. So in example number 1, positive acute angles A and B are being given, and they are saying that the cosine from angle A perspective, so if you're standing at an angle A, the cosine is going to be 28 over 53. Now, what does that mean? All that means that is if you're standing at your angle A, the adjacent side is going to be a length of 28, and the hypotenuse side length is going to be 53. Cosine in SOHCAHTOA is adjacent length over hypotenuse. Sine of angle B merely means that if you're standing at angle B, the length of the sides of the opposite over the hypotenuse are going to be a ratio of 12 over 37. Again, reminder, for sine S, it is the O over H ratio. So what we want to do is provide us a visual aid to help us label the given information, okay? So follow along with me and create two right triangles, because we're going to label one triangle containing angle A, and I'm going to use this acute angle here on the bottom right, and I'm going to use this acute angle on this triangle to be labeled angle B, okay? Now you can use the upper acute angle if you want to. I'm just using the bottom one, okay? So why did I choose those? No reason. If you wanted to label this one A and label this one B, or label this one A and this one B, it doesn't matter any combination as long as you choose an acute angle, all right? Now, for the first given statement, they told us that if you're standing at angle A, The adjacent side is a length of 28. Whoops, let me change my pen here. 28. And the hypotenuse side is a length of 53. So remember I said adjacent side is always the side that touches the angle you are standing at. Okay, so I'm going to say that again. Adjacent is always going to be that leg side that touches the angle A. This is obviously hypotenuse because it's across from the 90 degrees, okay? Sine B, they told us the length of the opposite side is 12. So across from angle B is angle, I said angle 12. The length of side 12, okay, that's the leg. And the hypotenuse length across from 90 degrees is a length of 37 units. So notice right now we do not have the length of this side, which in this case would be the opposite side. I'm trying to make this a little bit, there we go. And the length here, the adjacent side on the B triangle, is missing there, okay? So let's find what those missing measurements are. We are going to resort to using the Pythagorean theorem that says that the leg squared plus the leg squared will always give us the length of our hypotenuse squared, okay? So what are we going to do? Well, right now what we are missing is a leg squared. So notice we are missing one of the legs, all right, in the first triangle. So what I'm going to do is I'm going to subtract both sides by the leg so that I can solve for that missing side leg. So notice that when I'm missing a leg, all I'm going to do is subtract the hypotenuse squared minus the leg squared. And once I finish doing that, I must square root both sides to find the length of that leg. So that's what I'm going to do over here. I'm missing a leg. Okay, so I'm gonna actually write the word leg here to make it a point. And specifically, I'm missing the opposite leg. Okay, so because I'm missing a leg, I'm going to say the opposite side is going to be found by taking the square root of the hypotenuse squared minus the leg squared that has been given to me. And so when I put that all into the calculator, and I'll let you guys do all of that on your own, you will see that you obtain a length of a side of 45. So pause the video if you need to practice typing that out to make sure, okay? We are going to do the same thing on the other side. Why? Because we are also missing the length of a leg on this side, okay? It just so happens that the length of the side that's missing is the adjacent leg in this problem, in this, sketch of a triangle. So the adjacent side is found by taking the square root. Again, we start with our hypotenuse squared minus the other leg that was given to us. And when you do the calculations on that one, put it into your calculator, speed up the process, you get a length of 35. So 35 is what I'm going to put. So in green, I have put what was found. In black was given to us in our story problem, okay, or in our sentence. So now that we have constructed these triangles with all the given information, we are going to go ahead and proceed with working out in finding the value of cosine A plus B, which is the goal of this problem. Find the value of cosine A plus B. So if I go back upstairs, I want you to realize that all the sums and differences have been given, but this time, instead of saying in the formulas cosine A plus B, they used x plus y. So all you need to do is resubstitute capital A for every x and capital B for every y. So in this particular problem, our cosine A plus B is going to be cosine, get rid of that x, A instead of y, it's a capital B instead of x, A instead of y, capital B. All right, So we are going to evaluate cosine A plus B, and that's the formula right here that we need to use to be able to find that value. So let's rewrite it downstairs since we want to be able to visualize our triangles at the same time as our formula. All right, so let me do so. So give me a second to write that out. Cosine A plus B is equal to cosine A times cosine B minus sine A times sine B. So here's what I want you to realize, and I'm going to erase these little notes that I wrote up here. I want you to notice that I've been given some of that formula. Cosine A was given to me upstairs, and cosine A was given to be 2853. So right here in place of cosine A, I am going to put the ratio 28/53. I was also given sine B to be 12/37. So right over here for sine B, I'm going to be able to substitute 12/37. So let's go ahead and do that part, okay? 28/53, let's put it in place of cosine A. So 28/53, so I'm substituting. Cosine B I don't have yet. Sine B was 12/37, so I'm going to put it underneath sine B in place of, it's called substitution, 12/37. So I need to find cosine of B, and I need to find sine of A. We need to go to the sketch to find those values. So cosine of B, that means I need to stand right over here. Cosine means that I need to evaluate A over H, adjacent over hypotenuse. So if I'm standing right here, my adjacent is the side length that forms with the angle that I'm standing at. So this is my ADJ. That's adjacent over hypotenuse. This is my hypotenuse, 37. Okay, so 35/37 is what I'm going to put here for cosine B, 35/37. Now I need to go to angle A. I'm going to stand there at angle A, and this time for angle A, they're asking us to do the sine ratio. The sine ratio is O/H, opposite over hypotenuse. So if I'm standing right here, my opposite side is this side right here, and the hypotenuse is this side right here, 45/53. So in place of sine A, I'm going to put 45/53 side length. And all I need you guys to do is use your calculators to type out all the multiplication and subtraction of these two quantities. And when you do so, you should obtain the final answer to be a ratio of 440/1961. So pause and make sure that you are comfortable typing that out into the calculator device of your choosing. So let's continue here with example number 2. We are going to proceed with this problem the same way we did with the other one. The only difference is this time we are looking to find the value of the tangent of A minus B. Okay? So go ahead and pause the video here, and I want you to go ahead and construct the two right triangles just like we did in the previous section, the previous problem, not even section, in example number 1. So start off with two right triangles and label, and then come back to the lesson. So pause at this time. Okay, so at this moment, this is the given triangles that you should have drawn, and if you labeled the A and B acute angles to be the ones that I labeled, this is where the 15, 17, 3, and 5 should be located. Okay, so now I would like you to take the time to pause the video again and find those highlighted green spaces that are missing. Go ahead and apply the formula and then restart the lesson again. Okay, so here's the work in obtaining the missing leg on both triangles. All right, for this particular one in A triangle, we were missing the opposite side. So that's a leg. So we know we had to subtract hypotenuse squared minus the leg squared. In the triangle labeled with the B angle, we are missing a leg as well. In this particular one, though, we were missing the adjacent side. And so because it's a leg, again, you have to subtract hypotenuse squared minus the 3 squared, which is the adjacent side. The opposite side. Please note, though, I know that in example 1 and example 2, the missing side lengths were legs. There are going to be times that the missing length of a side will be the hypotenuse. So do recognize that if you're looking for an hypotenuse value, you are not going to be subtracting. You are actually going to take each leg and you are going to square them, but take the sum, okay? You're going to take the sum. So please make sure you recognize the difference, all right? Okay, so let me go back to our problem here. So now that we have labeled the missing side lengths to be the 8 and the 4, so the 8 was this side and the 4 is this side, we can proceed to evaluating the tangent of A minus B. Tangent of A minus B is going to be the ratio of tangent A minus tangent B over the quantity 1 plus tangent A times tangent B. So tangent A is what ratio? We need it to be O over A. In other words, opposite over adjacent. So let's go ahead and substitute every single one of those values. So I'm going to put my ratio line. Tangent A, standing here at angle A, is the opposite over the adjacent. So opposite over adjacent is 8 over 15. So let's substitute 8 over 15 minus the tangent of B. Tangent of B says to stand here, opposite over adjacent. This is my opposite, this is my adjacent. So 3 over 4. 3/4. In the denominator, we put a 1 plus the product of tan A and tan B, which we already wrote upstairs, so we just rewrite them. Tangent of A times the product of tangent B. And now all you're going to do is type that into your calculator device. If you're using the TI 84s that we have in the classroom, use the alpha y equals button so that you are able to come up with this stack fraction division bar. And then once you do that, do alpha y equals again, because you will need to create a stack fraction to start off with the 8/15. Type all that out and make sure that you are comfortable typing these stacked fractions within a fraction, and you will have the final answer end up being -13 over 84 for this particular problem. All right, moving on to example 3. Hope you ended up getting -1384 on the previous example. This is our last example for today's lesson. As you can see, we are going to proceed with doing the same thing we did last time. The value we're looking for this time around is the difference of angles A minus B, finding the sine of that difference. Pause the video. I need you to construct the two triangles, and I want you to go ahead and find the missing values all in one shot. Go ahead. I challenge you to try and do that and come back and check your answers. Okay, welcome back. So here's what your answer for those missing sides should be 2 and 2. I don't know if you constructed again your triangle like the way I did it, but if you did, here's what it would look like. Both cases you are looking for an adjacent leg. You're looking for the one next to where you were standing, the adjacent leg. I really wish I had created a problem where the missing side length was a hypotenuse one. So please make sure that if you do end up in your practicing of these type of problems, if you are looking for a missing side length that's a hypotenuse, please don't forget that you're supposed to add the squares of those sides, which are going to be the legs, and then square root them. You won't be subtracting, okay? So anyway, here is what you're going to do with these. Now that we have all the given information, we need to go ahead and proceed and evaluate using the sign difference formula. Sine of A minus B is equal to sine of A times cosine B minus cosine A times sine B. I have been given the sine of A to be 3 over square root of 13. And I've also been given the sine of B, which is 1 over square root of 5. So I'm just going to go ahead and put those in right off the bat. Sine of A was 3 over square root of 13. And sine of B was 1 over square root of 5. So I just need to find the other two ratios. Cosine of B, I'm standing right over here. Cosine is A over H. Making a note for myself here. A over H, adjacent over hypotenuse. So if I stand at B, I need to have the adjacent over the hypotenuse. 2 over square root of 5. So let's go ahead and put that. 2 over the square root of 5. Cosine of A has me stand right over here. Cosine of A is adjacent over hypotenuse. 2 over square root of 13. 2 over the square root of 13. Calculator, get at it. Type it exactly as you see it. Let it all work out. You are going to, actually, you know what? With these problems, now that I'm saying this, I think you need to do it step by step because of the radicals. So let's just do this step by step. 3 times 2, you get a 6. 13 times 5, both denominators are radicals. So 13 times 5 is a 65. And then I need to make sure not to forget my square root. I'm going to put my minus, multiply your numerator values. 2 times 1 is a 2. And then I need to multiply my denominator values. 13 times 5 is a square root of 65. My denominators are like terms. My denominators are the same. So I can combine by subtracting the 6 minus the 2, and that gives me a 4 over my common denominator of 65. Now, I need to remember that I must rationalize the denominator. I do not want my final answer to be a ratio or a fraction with a radical in the denominator. So we need to take care of that. So what does that mean? You guys have done this before. Take the fraction, if it has a radical in the denominator, and multiply it, numerator and denominator, by the radical you are trying to get rid of. Square root of 65 in this case. You're multiplying by a 1, so you're not changing the value of your initial fraction. So 4 times square root of 65 is just going to be 4 times the square root of 65. Put them side by side to imply a product, a multiplication. And square root of 65 times square root of 65 is 65. Why? Because when you multiply square root of 65 times square root of 65, it's just square root of 65 squared. The squared and the square root undo each other to then end up with 65 being isolated. So the final answer to this problem would be for square root of 65 over 65. And it can't be simplified any further, so we stop right there. So when it comes to these problems involving radicals, do not put it all in one shot into the calculator, because in the Delta Math assignment, you are going to have to give ratio answers that involve radicals, nothing involving decimals or rounding. So take your time in doing the steps that we just did in this final example. All right, good luck with the work. Thanks for watching. Reach out if you have any questions.